Question number 1 on Kirchhoff voltage law KVL. Find current in 4 ohm resistor. So this is 2 ohms. Then this battery is 12 volts. This is 2 ohms, 1 ohm. This is 10 volts. This is 3 ohms. This is 2 ohms. This is 12 ohm. Then this is 24 volts. And this is 4 ohms. So first step is assume the direction of current in all the components. So assuming the direction of current, this is I1, this is I1, this is also I1. Here I1 will split and form I1 minus I2. This is again I2, this is also I2, this will be I3. So this will become I2 minus I3. This will be I3, this will be I3, this will be I3. Here I1 minus I2 plus I2 minus I3. So I2 cancel, so it will be I1 minus I3. And incoming current will be I1. This will be I1. Why? Because it will be I1 minus I3 plus I3. So incoming and outgoing current both should be I1. This is the outgoing. This is the incoming. So incoming current will be I1. So we have assumed the direction of current in all the components. Next is step is mark plus and minus as per sign convention in the resistors and plus and minus as per polarity in the voltage source. So current is entering over here. This is positive, negative, positive, negative. Then this is positive, negative, positive, negative, positive, negative, positive, negative, and as per polarity in the voltage source. So this is positive terminal, this is negative terminal, this is positive, this is negative, this is negative, this is positive. Now apply the KVL. So apply KVL to the loops equal to the current either in clockwise or anti-clockwise. So first we will say that this is mesh number 1, mesh number 2, mesh number 3. Apply KVL to mesh number 1, mesh number 2 and mesh number 3. So when I apply KVL, and we should assume the direction to be clockwise for simplicity. When I apply KVL to mesh 1, what do I get? Or to loop 1. Starting from this point, it will be plus 12, positive to negative minus 2 I1, positive to negative minus 12 I1 minus I2, positive to negative minus 1 I1 minus I3 equal to 0. So this is 12 minus 2 I1 minus 12 I1 plus 12 I2 minus I1 plus I3 equal to 0. Collect the I1 terms. 15 minus 15 I1 plus 12 I2 plus I3 equal to minus 12. This is equation number 1. Next is apply KVL to loop number 2 or mesh number 2. So starting from this point, negative to positive is plus 12 I1 minus I2, positive to negative minus 2 I2, positive to negative minus 10 I2, minus 10 because it is a voltage source, and then minus 3 I2 minus I3 equal to 0. So 12 I1 minus 12 I2 minus 2 I2 minus 10 minus 3 I2 plus 3 I3 equal to 0. So 12 I1 minus 2 is I2, 3 is I2, so 5 and 17 I2 plus 3 I3 equal to 10. This is equation number 2. Apply KVL to loop 3 starting from this point. Positive to negative, minus 4 I3 plus 24, then plus 1 I1 minus I3, again minus to plus, so plus 3 I2 minus I3 equal to 0. Minus 4 I3 plus 24 plus I1 minus I3 plus 3 I2 minus 3 I3 equal to 0. So I1 plus 3 I2 minus 8 I3 equal to minus 24, equation number 3. Solve the equation simultaneously using the calculator. So what do I get? Minus 15 equal to 12 equal to 1 equal to minus 12. 12 minus 17, 3, 10, 1 minus 3, plus 3. Minus 17, 3, 10, 1, 3, minus 8, minus 24. So current through 4 ohms, current through 4 ohms equal to I3, which is equal to 4.1114 amperes. Let's see the next question. Question number 2. Find the current. Find the current in 10 ohm resistor. Find the current in 10 ohm resistor. So this is there 5 ohm given. This is given as 4 volt. This is given as 15 ohms, 10 ohms, 8 ohms, 12 ohms, 6 volt, and this is like this, okay. First is assume the direction of current. So suppose I1 enter. So I1, 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 I2. So I1 minus I2, I3. So I2 minus I3, I3. This will also be I3. This will be I2 minus I3 plus I3, I3 cancel, so I2, and this will be I1 minus I2 plus I2, I2 cancel, so I1, and this I1 will come in the circuit again. So the directions are assumed: polarity positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. This is positive terminal, this is negative, this is positive terminal, and this is negative. Now applying KVL. So consider this as 1, consider this as 2, and consider this as 3, and apply the KVL. So first is apply KVL to loop number 1. So starting from this point, if I apply, it is negative to positive plus 4 volt, positive to negative minus 5 I1, positive to negative minus 15 I1 minus I2 equal to 0. 4 minus 5 I1 minus 15 I1 plus 15 I2 equal to 0. This is minus 20 I1 plus 15 I2 plus I3 term is not there, so we'll write here 0 I3 equal to minus 4. This is equation number 1. Next is apply KVL to loop number 2. Why do we write here 0 I3? Because in the calci third variable also has to be inputted. So if we write here minus 4 in the calci, answer will go wrong. So for safety we write 0 I3 so that we remember we have to put a 0 in place of the Z. Apply KVL to loop number 2 starting from this point. Negative to positive is plus 15 I1 minus I2 minus 10 I2 minus 8 I2 minus I3 equal to 0. So this is 15 I1 minus 15 I2 minus 10 I2 minus 8 I2 plus 8 I3 equal to 0. 15 I1 minus 23 plus 10. So this is 33 I2 and you have your plus 8 I3 equal to 0. This is equation number 2. Next is apply KVL to loop number 3. When I apply KVL to loop number 3, starting from this point, I get negative to positive plus 8 I2 minus I3, positive to negative minus 12 I3, then you have a minus 6 equal to 0. So 8 I2 plus 8 I2 minus 8 I3 minus 12 I3 equal to 6. So 8 I2 minus 20. Okay, here I forgot 0 I1 equal to 6. This is my equation number 3. Now solving these equations simultaneously in 3 variables. So minus 20, 15, 0I3 minus 4, then 15I1 minus 33I2, 8I3, 0, then 0, 8 minus 20 and 6. So current through 10 ohms is current through 10 ohms they have asked. So we'll write here current through 10 ohms equal to I2, which is equal to 0.0323 amperes. 0.0323 amperes.